Well, greetings, geometry students. This is Mrs. Bigelow, and here is my second attempt at teaching, and putting it on YouTube for your benefit. So today we're going to talk about using medians of a triangle, and I'm teaching from page 279, so you'll want to go ahead and flip over there before I start teaching. So I will wait while you get your books and open up to page 279. Alrighty, so we are talking about using medians of a triangle. We've been talking a lot the last week about bisections, bisecting sides, bisecting angles, and where those bisectors meet, we call the point of concurrency. So today we're going to talk about another bisection called the median. The median is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. So I'm going to draw us a triangle. Okay, I'm going to pause it because it's not drawing the triangle. There we go. Alrighty. Okay, so let's just draw a random triangle. Alrighty. So I'm going to take the midpoint of each side. Let's see, 1, 2, 3, 4, 5, 6. The midpoint of the base here is right here. So that's a midpoint right there. So if I take a line and I take it through that midpoint, I'm not quite sure what's happening here. Oh, it's erasing. Let me start over again. I forgot there's an erasing feature on this pen that if you push down on it, it erases. So let's do this again. Okay, so let's try this again. So I'm gonna guess that the midpoint on the bottom's about there. So I'm gonna take a line segment and I'm gonna take it over to that opposite side. This tablet is kind of hard to draw a straight line on. It's slick. So anyway, so now I know that this line segment is congruent to this line segment. And I'm going to take the midpoint over on this other side here, and I'm going to take it and I'm going to draw a line segment straight over to the opposite angle. And here's a third one. So that means this line segment is congruent to this line segment. And I take a line and I go straight over. Those are called the medians. They bisect a side, and then from that midpoint, the bisection, the median, goes over to the opposite angle. So those are medians. The point of concurrency here in the middle is called the centroid. Alrighty, so again, the medians bisect the sides and they cross over to the opposite angle. Now, one point I want to make is that these medians, they bisect the side, but not necessarily the angle, the opposite angle. Okay, so there's your medians, there's your centroid. I have one. Figure out how to do this. I'm trying to just scroll down. Oh, there we go. Okay, we have one theorem. There we go. Alrighty. So the concurrency of medians of a triangle theorem. It is on page, let me see here, I believe it's on page 2. Oh, it's on 279 also. So what this theorem says is if you have your you have your three medians. Here's the midpoint, and here is my median. I'm going to guess the midpoint's about there. The median goes from there over to the opposite angle, and on this leg, I'm going to like that. So there's your three medians. We know that's congruent to that. That line segment is congruent to that line segment, and these are congruent. So there's my three medians. What this theorem says is, let me label the triangle for you. Alright, so this theorem says the medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So what we're saying is the length of line segment AP, notice, goes from here to the centroid, is equal to 2/3 of the length of the whole median. Likewise, BP, oops, I hit that erase feature again. BP is equal to 2/3 of BF, and CP is equal to 2/3 of CE. So let's put some numbers in here and help you with that. So let's just say that the length of line segment is AP. I'm sorry, that did not make sense. The length of line segment AP is 6. So I'm putting the 6 right here. And I want to figure out what the length of the whole median is, and what the length of the other section of the median is. So I'm going to use this theorem right here, this formula, and I'm going to say AP is 2/3 of the whole median. This is where this erase comes in nicely. So what I'm saying is, I know AP is just 6, right? So 6 is 2/3 times the length of AD. So to solve for this, the length of AD, I multiply both sides times the reciprocal. And I get that the line segment AD is 9. So the whole line segment is 9. So that would mean the length of line segment PD is going to be just 3. Alrighty, let me do one example and then I will get this on YouTube for you guys. Alright, so say we have this triangle here, and we have our median over to there. Okay, so we know this is congruent to this is congruent to this, and this is congruent to this. And let's label these. And let's solve that point in the middle of the P is kind of nice. Okay, so if I give you the information that PT is 5, the length of line segment PT is 5, how am I going to find RT and RP? So I know this line segment right here is 5. Notice that that is not the section of the whole median that's coming right out of the angle. So I'm going to switch this up for you a little bit. I know that PT is 1/3